So here we are, another question on probability, and we'll probably use a Venn diagram for this one. So here we've got two events, N and M, and we've got some probability information there. So I think a Venn diagram is in order. So there's our Venn diagram. Now we can't actually complete any of the Venn diagram without doing a calculation. And the calculation we can do is to use the formula for conditional probability to work out the probability of N and M. So that's probability of N times the probability of M given N, and that's 0.15. So that's the probability of N and M. That's this bit in the middle. So that figure is 0.15. Now we know also that the probability of M on its own is 0.3. So the whole of M is 0.3. Given that this bit here is 0.15, then the probability of the remaining section must be 0.15 also. The probability of N is 0.5. That's all of that. So we take off the 0.15 to give us 0.35 for that sector there. And then when we take all of those numbers away from 1, we find 0.35 here too. Okay, so now we can set about answering the questions. Question A to begin with. Let's find the probability of M or N. Probability of M or N is the probability of M plus the probability of N minus the probability of M and N. So that's 0.65. We could do that another way. We could simply add these three numbers together. Okay, we've also then got to find the probability of N given M. So the probability of N given M is the probability of N and M divided by the probability of M, which is 0.5. So the third part of part A is this, the probability of not N and M. So that's probably, you can do this a number of ways. Not N and M is this part here. So that's 0.15. You can do that by taking the probability of M and subtracting the probability of N and M. Okay, so part B, explain whether the events M and N are independent. Well, there's a couple of ways of doing that. The first way is to compare the probability of N given M and the probability of N. And if they're the same, then that means N and M are independent. We could also do the probability of M given N and compare that with the probability of M. And the probability of M given N is 0.3. Probability of M is 0.3 as well. So they're both the same as each other. And so that's another way. A third way to test independence is to compare the probability of N times the probability of M with the probability of N and M. So again, we get the same results, that they are independent. Then part C, we need to show whether they are mutually exclusive or not, and there are two ways of doing that. First one is to state that the probability of N and M is not equal to 0. So this bit here is not equal to 0, and therefore they can happen at the same time, and so they're not mutually exclusive. Another way of doing it is to compare the probability of N or M with the probability of N plus the probability of M. And since they're not the same, that's another way of showing that they're not mutually exclusive. Okay.